So before start a discussion on the today's topic, I would like to tell you please subscribe my channel. So you can see on this channel up till now I have covered the project on Arduino, project on the Raspberry Pi, project on the Python programming web application, and all the project details I have covered from very basics to advanced. So if you want to learn the Raspberry Pi, Arduino, Python web application designing from me, please subscribe my channel. All the projects are free and I will not take any single rupees from you for that projects. Only point is you have to watch the complete video and try to execute all the project at your end. From today onwards, I will add the new playlist, that is the pic microcontroller application designing. So in this playlist also we will try to cover more than 50 topics. So if you want to learn the embedded system again from me, then please subscribe my channel, please support me. Hello friend, in today's session we will learn how we can design and develop LED blinking project with pic microcontroller. So you can see on the screen we have the pic microcontroller and we have the simple LED. So from today onwards we will try to cover all the project on the pic microcontroller. Definitely I will try to add more than 50 videos on the pic microcontroller so that you will get idea each and everything about this pic microcontroller. So before start the next part, I would like to tell you what will be the final output of this project so that you will get idea about what you will learn at the end of this video. So once I run this project, so you can see LED start on and LED start off. So blinking of LED, that is simple application we will design. But in this video I will try to cover all the topic, that is how to design this pic controller circuit in the Proteus software. Also what is the logic behind the each and every line of the code. So if you want to learn complete project, that is hardware designing and the programming part of this pic microcontroller, so please watch this complete video and try to learn new thing. So before executing this pic microcontroller in your laptop, that is before connecting the before creating this circuit design in your laptop, it is very important you should have the pic microcontroller application, that is MPLAB ID application. Here what we will do, we will write our software, we will compile the file. Another software require the Proteus 8.9 and you require the C compiler, C18 compiler. So how to install this MPLAB IDE software and see it in compiler in your laptop, I will tell you. First of all, you have to go to my first of all you have to download the basic setup, that is basic setup file, software file which is required for this project. So first file is C18 compiler, second file is MPLAB IDE. I will put all these files into the Google Drive link, the Google Drive link given in the description. So once you download all this setup file from my Google Drive link, first you have to open the C18 compiler. So once you open the C18 compiler, then you have to double click on this software. So once you double click on this software, there is one installation guide I will provide in this Google Drive link. So you have to open that installation guide and you have to follow that step so that C18 compiler will be installed in your laptop. So I will open that guide so that I will tell you what are the exact step you have to follow. So once you open the C18 compiler, you can see this window will be open. MPLAB something MPLAB pic18 MCU. Then click on this next button. Then after that you will find this one, a license agreement. Then click on this accept license agreement. Click on this next button. Then wait for complete system installation. Just click on this next button whenever you find. After this license agreement, accept the license agreement and just click on this next button. Then after that, once the compilation finish, then click on this finish button, and after you click on this finish, then this C18 compiler will be installed in your laptop. Then once the C18 compiler installed in your laptop, next you have to install the MPLAB IDE software. So again this software link I will provide in the description. Go to this folder and click on this setup file. So once you click on this application file, then this window will be open. This window will be open. Just click on this next button, then accept the license agreement, click on this next button. Then select this complete project, click on this next button. Then select this setup, wait for till this installation complete, and once complete you can close this window and click on this finish button. So once it's finished, then you will find the MPLAB setup in your laptop. You can see MPLAB IDE setup in your laptop. Then next software you require the Proteus 8.9. You can go to the YouTube and just search Proteus 8.9 software, and you can easily available this software anywhere, or if you have the any software Proteus 8, that also okay. So these are the basic steps you require before start this project hardware connection. Now once you have the Proteus 8.9 software and MPLAB IDE, first we will design the circuit. So if you want to design circuit, just go to the Proteus software whatever you have, right click on the software, run as administrator. I am using the Proteus 8.9 software, so if you want setup like me, then you can go with the Proteus 8.9 software, or you can use Proteus 8 also. Then after you open the Proteus software, just click on this new button, new project button. Then after that, here you can give the project name, like let's say blink led. I am giving this project name. Then you can give the path of that project wherever you want to save that project. Then just click on this browse button and just create the one folder, and here in that folder you can paste that project as it is. So this is the just path of that your project. Then after that, you can click on this next button, select this create a schematic from the selected template, click on this next button, select this do not create a PCB layout, click on this next button. Then you can see no firmware project selected. Then click on next button and click on finish. So once you click on finish, the blank window will be open, and here we will design our circuit. So first we require the pic controller. So which pic controller we will use, I will tell you just now. The pic controller we will use this pic18f4550. So where you find, just open your Proteus software, go to the component mode, click on P and type here pic18f4550. So once you type this, you will find this pic controller. Just click on this, click on OK button and place that controller here. So once you place that controller, very important point is you have to connect this VP pin to the power. So just go to the component terminal mode and click on this power button. So once you click on this power button, place that power here and connect the power this like this to last pin, this pin, VP pin. So this part is completed. Now the next part is we need our LED circuit. So how to take the LED? Just go to again component mode, then click on P and type here red LED. So once you type red LED, just select this red LED from here, click on OK and place that LED there. Now after that, you can see the negative part of that LED should be connected to ground. So where you will find ground, just go to the terminal mode and click on ground button and place that ground to ground here, and then connect that ground to ground. Then after that, go to the terminal mode, click on default and place one default pin here. Right click on this pin, rotate clockwise, shift here and connect both terminal of LED should be that default pin. So up till now this circuit is completed. Now the next part is we have to connect this pin, that is this default pin, with RC0 pin. So again we require one default pin from the controller. Select this terminal mode, create default pin and place one default pin here. Right click on this pin, rotate 180 degree. Then after that connect with RC0 this pin to here. Then after that double click on the default pin, you can give here name LED, click on OK. Double click on this default pin, click name LED, OK. So in this way you can see circuit diagram is completed. Simple and very easy circuit. Then after that, if you want to give the name to the circuit, just go to the box and create this, click on this pin button. So once you pin, draw the box wherever you want, and if you want to give the name here, just go to the A, click on this pin, type here and click give the name LED. You can increase the size whatever you want and click on OK. So in this way our circuit part is completed. Now we will switch to the programming part. Now we will see the programming part of this circuit. So if you want to open the program, just go to the MPLAB IDE software, double click on this software. So once you double click on this software will be open. Wait for some second. Then after that, go to the project wizard, go to the project, then click on project wizard, then click on next button. So once you click on next button, here you can type pic18f4550. That I have already typed here. Just type this control here, then click on next button. So once you click on this next button, select this toolkit and here you will find C18 compiler that we already installed. Click on this and just select this C18 compiler from here. You can see MPLAB C18 compiler. So from toolset I have selected it C18 compiler. Then click on this next button. Then here you can give project name, whatever the project. So just click on this browse button and create new project wherever you want. So let's say I will create my new project here. So new, then folder, and here I will give the blink, this folder here, new folder is created. Go inside that folder and give project name as a blink and click on save and click on next button, and then click on next button and click on finish. So once you click on finish, just go to the file and create a new file. So once you create a new file, just type anything on this file. Once you type anything, just control and save. Once you control and save, again go to that folder, you can see blink, go inside that one, select the this file name as a blink or any file name you want to give, blink.c. As a .c you have to save with extension .c, blink.c, and click on save button. And then after that, just click on this source file, right click here, add files. So once you add a file, the blink file, you can see .c file, whatever file just created, just open that file. So once you open that file, the file is created here. Now in this window, the file is created, double click on this file, the file will open, and in this file you have to write your code. So I have already written my code, I will show you that code, and also I will provide that code to you, the code given in the description. So this is my code, you can see this notepad file, I will give you C file, LED blink, this one LED2, right click on this file, open with notepad plus plus. So once you open, you will find this file as it is there. So you can control C, control A. So once you control A, copy this file completely. Once you copy this code, just go to the MPLAB ID and paste whatever the code we copied, just paste here. So once you paste, the code is already created for you. And then after that, if you want to check the it's working or not, just click on this build all button. So once you build all button, you can see here you will get the message hex file is created, converted, build successful. That means whatever the code you have copied, that is correctly copied. Now we will see the importance of each and every line from the code. Now here first line is hash include pic18f4550.h. So whatever the controller you are using, that header file you need to include here. Then after that you can see oscillator is HS, whatever the oscillator we are using, watchdog timer we are turning off here, low voltage disable program we are turning off here. So these are the basic setting. Then after that, very important point is line number, this one. So you can see I have hash define. Hash define is nothing but in the C programming, if you want to use any let's say any port, so this is the port from the project, you can see pic controller. So in the pic controller, if you want to use any port like RC2, I am using for the LED2. So you can see RC2 I am using for the LED2. So while like you can see while we designing this circuit, just one small mistake I have done here. Instead of RC0, we have to connect this LED to RC2. So right click here, delete this line, and then after that you can connect this LED to RC2 here like this. So like this is only small mistake. Okay, so what the my point is, in the pic controller program, if you want to use the port, you can see here all the ports. RA is a port, RA from 0 to 6, it is a one port. Then RB from 0 to 6, 0 to 7, this is another port. Then we have the RC port, then we have the RD port. So all these are the four port. So if you want to use any pin from this port, let's say RC2 we are using, that is connected with the LED. So if you want to use that pin for the LED, you can define like this, hash define LED. It is a user defined name, LED is a user defined name, you can give any name here, but this one is not user defined. So this is the register, you can see port C, that is port C, we are using the port C. As per the circuit diagram, we are using the port C, but from the port C which exactly pin, because in the port C we have 0 to 7 pin. So from 0 to 7 which exactly pin is connected to the LED. So you can see here we have defined from port C bits RC2 dot RC2. So this is the we can say syntax for the PIC microcontroller to define any pin, input output pin. So LED pin which are connected to the port bits RC2, that is nothing but the RC2 pin is connected to my LED. So this is the use of this line. Then after that you can see there is one function. So function, here we have declare just. So what declare means, we have given the idea about that function. What is the function return type, then what is the ms delay, that is the function name, then integer, what is the input value of that function. So function is just defined here. Then after that you can see our main function is started. Then after that you can see there is a trace register. So trace register in the PIC microcontroller told that it is given the idea that whatever the pin, so you can see on the PIC microcontroller each pin, so each pin are actually used as a multi-purpose. So RC0 pin as used as an oscillator also, clock also. You can see RC array 0 pin used as analog pin also, digital pin also. So exactly what is the purpose, what is the purpose. So you can see RC6 pin used as a TX pin as in a serial communication, RC7 pin used as a RX pin also, then SDO pin also, then CK pin also. So exactly what is the use of that pin, that is given by the trees. So if you want to configure RC2 pin as a output pin. Why output? Because this PIC microcontroller will send the signal to on this LED. So this PIC microcontroller send the signal. So that's why the signal coming out from the PIC microcontroller. So that means the microcontroller pin work as a output pin. So the PIC microcontroller RC2 pin work as a output pin. So that we have to define by using trace register. There are another register. First register we saw port register. By using port register we are like selecting which pin we are using, and in the trace register we are selecting which functionality of that pin we are using. So trace set bit, you can say trace set bits dot trace C2, because we are using RC2, that's why here C2 is equal to 0. So to configure the pin as output, so that's why this line is here. So our pin will be work as a input output pin now. This RC2 pin work as an input output pin. Then to turn off this pin means, if you want to turn off this LCD, here to turn off this LCD we have to give the zero signal, on this RC2 pin. So how to give this zero signal on this RC2 pin? This port register, port C bits RC2 should be equal to 0, but at the starting we have defined this is nothing but the LED. So LED is equal to 0. So whenever the compiler, that is see it in compiler, will compile this program, this LED, you can see this LED word will be replaced by this trace RC2. Indirectly it will replace this like this. So whenever in like, if you want to give some user defined control in your program, that is user friendly, so uh, like I can give the name of this some line. So whenever I require this line I can give this LED. So that's it only. So LED is equal to 0. So that means LED will turn off. This is nothing but the micro. In the C language you can search on the internet how to use the micro. So we have defined the micro. So whenever there is LED, that is replaced with this micro. So LED is equal to 0. That means port C bits is equal to 0. That means our LED will turn off initially. Then while one. So while one is basically I have used because I want to turn on and turn off the LED for the infinite number of time. Whatever the code in between these two bracket, that code will be executed for the infinite number of time. So once that LED is off, I have to turn on the LED. So how to turn on the LED? I just have, I just want, I just send one signal on this pin. So how can I send one signal? I will just type LED is equal to 1. So that means this port C bits RC2 is equal to 1, and it will turn on because it will send the one signal on this pin and LED will turn on, as simple. Then after that some delay, so you can see some delay logic is here. Then I want to turn off the LED, so again I will use LED is equal to 0 and some delay. So in this way this program will be executed for infinite number of time, and LED will start on and off, on and off, on and off. So this is the code, this is the logic behind this project and the program and hardware connection. I hope you understand the program and the hardware connection. Now we will see how to run this project. Now we will see how to run this project. Now if you want my ready-made project, you can follow this step. So first you have to open the Proteus software, click on run as administrator, click on yes button. So if you want my ready-made project, you need Proteus 8.9 software, otherwise you can follow the hardware connection explanation and you can design your project by yourself. Then click on this open project. Then once you click on open project, just go to my downloaded folder link from my Google Drive link. So Google Drive link I have given in the description. From that link you will find this project LED Blink. So go inside that one and you will find this LED Blink Proteus project and click on open. So once I open this project, you can find this ready-made project that is available. But if you want to design, I already told you how to design this project by yourself. Then after that we require the pic microcontroller hex file. So double click on this MPLAB IDE. So once you double click on this MPLAB IDE, you can go to the file and click on open workspace. So once you click on open workspace, you can the ready-made workspace available to you. From my side you can see this is the ready-made workspace Blink. So I also add this workspace in the Google Drive link, you can download and click on open button. So ready-made you can find all the source file attached here, all the code are attached here. So if you don't want my ready-made, you can follow my video steps and you can design and develop this workspace by yourself. Then you can click on this build all. So once you click on this build all button, you can see there is hex file is created at this path. So copy this path, select this path and copy till hex file. So once you copy it, just open the Proteus software, then double click on this pic controller, click on this folder and paste that path, click on OK, and hex file you can see loaded here and click on OK. So once you load hex file, just click on the save button and click on this run. So once you click on this run button, you can see project start working here. So in this way we completed the first project, that is the first very basic project, how to connect the LED with PIC microcontroller. In upcoming part definitely I will cover the ADC, GSM, GPS, we will cover many projects on this PIC microcontroller. So please subscribe my channel and please support me.